Hello, welcome to Module 13, Video 2, and as I mentioned in the previous video, in our first video, we're now going to take a look at a few rules. So you have here a script file with a bunch of iptables rules, and we are going to take a look at some of them. So first of all, I have here, and as you can see, it's pretty well commented. Basically, I am going to first flush all rules that I have. I'm going to use the -F option to erase, delete all the rules that I have. Now, in which chain? If I don't specify the chain, I am saying that I want to flush rules of all chains. But I am not just doing iptables -F, because once again, if I do iptables -F, I'll be flushing rules from the default table, which is the filter table. I also want to make sure that I flush all rules, any rules. It doesn't matter which table it is. Well, in that case, I have to specify those tables. So I'm flushing rules out of my Mango table, I'm flushing rules out of my net table, and obviously from my filter table. If I want to do simply iptables -F without the -T filter parameter, I can do that. Once again, the filter table is the default, so I do not need to specify it. Now, first of all, let's understand what these other two tables are about, the Mango table and the net table. But let's first understand the net table, and then we'll jump into the Mango table. So the net table is the table that you use to perform network address translation. And what is that? Well, it's what you know as network address translation in its standard way, which is changing information, changing data associated with network traffic. For example, if you want to reroute traffic, you can use create rules, add rules to one of the chains that you have in the net table. If you are translating network address, you have to apply rules to the net table. So once again, if you are changing data, but that data is associated with network address, which means source IP address, destination IP address, source port, destination port, then you should add rules to the net table. Once again, keep that in mind. Network address translation. It is associated with changing values regarding source IP address, destination IP address, source port, destination port. Now, you have some other types of data in a packet. Well, to all those other types, I am not going to use the net table. I am going to use the Mango table. So let me give you an example. A packet you may change a type of service, TOS or TOS. By most of the traffic packets, their type of service, their TOS, is set to a default value, which is 0. What that means is, if you have two packets, both of them have the default TOS, which is 0. There is no priority. They are competing between themselves, and they're just going into a queue according to when they arrived. Now, if you want to give priority, you can change that TOS. You can change the type of service. There are different types of services that will give higher priority to one packet in regards to the other one. To do that, you're going to use the Mango table. You're going to add the rules to the Mango table. So once again, if it's not source IP address, destination IP address, source port, destination port that you want to change something else, you're going to use the Mango table. Okay. Then what I am going to do is to delete all user-defined chains. If there are chains that were created by the user, they're not the default chains. If it's not input, output, forward. Now in the net table, we also have pre-routing and post-routing, additionally to the forward chain. If you have more chains other than the standard ones, you want to delete those ones. And the way that you do it is by using the -X option. Then, as previously discussed, you have to define the policies. And as you can see here, you should define the rules to the policy for those chains to drop. Again, since I'm not specifying the table here by using the -T option, I am referring to the filter table. I'm defining the policy to those chains as drop. And then you can start defining specific rules, adding specific rules to specific chains. For example, right here, what we do is I am adding, once again, I didn't need to do this, but I'm doing it just to be very specific. I'm adding a rule to my output chain. And what rule is that? Packets that are leaving from my ETH1 interface. And the transport protocol is UDP. The destination port, that packet is going to port 53. That's the DNS port. I'm using a module, which is the state module, that says if this state is new, that packet should be accepted. Okay, let's understand what it means. Again, I have a packet. I'm adding a rule to my output table. So I'm creating a rule to be associated to match, that should match packets that are being generated in my machine is going to go, and it's going to go somewhere. So there's a packet that is, whenever that packet exists, leaving my machine. It's my machine sending a packet. What type of packet? A packet for a DNS server, because the destination port is DNS. That means once my machine wants to communicate with a DNS server, my machine wants to ask for a name resolution. If it's a new connection, it should be accepted. There is a module, and there are a bunch of different modules. In this case, I'm using the state module, and traffic can have different states. You can have new, you can have related, you can have established. Here I'm saying if it's a new type of traffic, then I should accept it. I do the same thing for the SSH port. I do the same thing for the 2064 port. And I also want to allow my machine to send pings. A ping is a ICMP protocol, specifically ICMP type echo request. So in my ICMP protocol, I have the --ICMP type, and then I specify the ICMP type. When I'm sending a ping, I'm sending a echo request. Now, if I want to be able to send pings, I obviously want to be able to accept pings. However, I do not have that rule over here, a rule that accepts ICMP echo reply. I should have that to make sure that my machine is going to accept the response to my request. I don't have it, but I should have if that's the case. And then you have some other additional rules here. But again, you're just using a combination of options according to the type of traffic that you want to create. Similarly, as I mentioned about the ICMP echo reply, I do have the SSH reply. Remember, it's just like that to all traffic. When I send a request, I want to get the response. Well, if I allow my machine to send traffic, I should have a rule accepting the response. So here, I'm saying that I want to send SSH, and I have another rule here saying that I want to accept a connection to that port. Now, you can see here that what I'm using is destination port. You also have the -- source - port option. So I should also have a rule saying that, for example, iptables -t filter -a input -i, and what is my input interface? It's ETH0 -ptcp - source port SSH. That should be the rule to match this one. I'm saying, hey, I want my machine to send packets to a SSH server. If that SSH server responds, it's going to use its SSH port 22, to respond. So, which means that the SSH port is going to be the source port, not the destination port. And once again, you have just a combination of different rules according to the type of traffic that you want to do. Now, just to finalize, let's take a look at the net table. Let's take a look at this first example. I am now using the net table. What is it doing? I'm adding a rule to my pre-routing chain. And I also have the post-routing chain, and you need to understand the difference between those two chains. But let's take a look at this one first. Pre-routing. Pre-routing means before routing a packet, before deciding where to forward that traffic to. Before routing a traffic, I want, and let's say that this packet is arriving to my ETH1 interface. So, first of all, pre-routing. That means that I'm talking about a machine that is routing. So, if this packet is arriving to my ETH1 interface and the destination port is 80, okay, so I'm considering a packet that is going to arrive to my machine and getting to my port 80. What I do want to do is to use the destination net target. Means that I want to change the destination. I want to apply, I want to change either source port, destination port, source address, destination address. But if it's a destination net, that means I want to change the destination. I do have the SNet or source net. That's when I want to change a source. So for destination nets, I can change the destination port or the destination IP address. If I want to change the source port or source IP address, I should use the SNet target. So what am I doing here? Again, if there's a packet arriving to my machine on interface ETH1, the destination port is 80. What I want to do is I want to change the destination to this IP address here in this port. And it's pre-routing. Well, obviously, if I want to change destination should be changed before routing traffic. Why? Well, because you are changing the destination. and a destination, what a router is going to do is to route traffic. If you change destination after routing the traffic, there's going to be no impact. You have to decide what to do with the destination values before routing. You cannot change after routing. So it's the pre-routing. On the other hand, you also have post-routing. Post-routing is something, so first of all, in other words, what it's doing is, if a packet is coming to my machine in port 80, I want to forward that traffic to another machine in a different port. So one situation that you can see this happening is, this is a firewall or a machine that has a public IP address. It is directly connected to the internet. But the company's website is stored in a web server inside my network. As you can see, it has a private IP address. It's not a public IP address. It's a reserved IP address. Well, clearly, my clients, the users, they cannot from the internet reach that web server. So what I do is I give them my router's IP address, which is a public IP address. But once that traffic reaches my router's or firewall's port 80, it is going to be redirected to my actual web server. That's one way of doing that. Now, the other type of NAT that we can commonly use is the post-routing. That's once you want to change network address values after routing. So let's say that you have a router. After the packet is routed, you want to change some source values. It can be the source IP or source port. A very common type of post-routing is to masquerade an IP address. A scenario, well, let's say that you have, once again, this machine here is in my LAN, my local area network, with a reserved IP address. This machine cannot access the public network because it doesn't have a valid IP address. What I want to do, and this is not the rule, I would need another rule. So let's see right here. This IP address, although this is not reserved, but I want to make sure that once this IP address, this node here, passes through my router, I want to, once it's been forwarded, once it's been routed, decided what to do, I am going to change its source IP address to this one. So again, this client is going to access the internet. It can't. This machine here is the router. Once this node sends its packet to this router is going to do, okay, I'm first going to route this packet coming from this guy over here. But once it's been routed, I'm going to say that the source address is this IP address, which is the router's IP address. The traffic has been routed. After routed, I changed the source IP address. Once it gets to the destination, which is, let's say, a FTP server in the public network, in the internet, that server will try to respond to this client. What is the IP address it's going to respond to? It's going to respond to this IP address, which is not the original client. It is actually my router. Once that response gets to my router will say, oh, okay, so it's a response to a packet that I source netted. Now I'm going to forward it back to its original sender. So that's what you use the NAT table for. And then finally, you have to make sure that if it is a router, if you want, if you're configuring a machine that is supposed to forward the traffic, which means packets that are arriving into to an interface and then being forwarded through another interface, IP forwarding should be enabled. To enable IP forwarding, you can either edit the /etc/csctl.conf file, and there is a directive there to do such, or you can do this. You can change the value of the /proc/sys/net/ipv4/IP forward file. The default value is 0. You change it to 1. Now, one very important information is that this file is in the /proc directory, which means it's a virtual directory. This file doesn't exist. If it doesn't exist, if the machine is rebooted, or simply if the network is restarted, the network service is restarted, this file's value will go back to 0 and you have to redefine it. So this is how you're going to take this is the knowledge that you're going to need for the LPI C2 exam. You need to understand how you use IP tables. You need to understand the options. What is a chain? What are the tables? What do you use those tables for? What are the main options? What is a target? And don't forget the main chains in the filter table, input, output, forward. In the net table, you also have the pre-routing and post-routing chains. I hope you enjoyed this video. Thank you very much.